Hello everybody on YouTube. What I want to try and do in this video is to try to repair this knurling tool that I've got here. The problem with it was somebody had tried to make some homemade pins to go into this part here which holds the knurls in position. I'll just show you where the knurls fit. They'd made them out of mild steel and there was about 2mm of play on the knurl going up and down. Just zoom in a little bit so you can... And there's about 2mm of play on this knurl. They'd put the pin in and hammered the ends over, and I think what's happened is the pin has been spinning round in these holes here, and as you can see there's a certain amount of play in them holes. So what I want to try and do is, I've got some old high-speed steel milling cutters. And they've got a thread on this end, so what I want to try and do is I want to try and machine a slot at this side so I can clip a circlip on, and then I can tighten a nut onto this side which will lock the high-speed steel in position so that when you apply the knurls to the metal, the high-speed steel pin will stay still and the knurl will spin on the actual pin itself. What I don't want to happen is the pin spin round in the holes, making these holes even bigger than what they actually are. The problem is with high-speed steel, it's going to be very difficult to machine a slot in this end here. So I'm going to have to try to mount my multi-tool into the lathe to put a small slot in there and try and grind a slot in there so I can clip a circlip on. So that's what the goal is on this video. I'm going to be using the 0 to 0 method of cutting this thread. I've set the top slide to 27 degrees. The backlash has been taken out of the top slide and set to 0. I'm going to start the machine up now and get the cutter to just and so touch the inside edge. The tool is now just and so touching the inside edge of the bow, and I've adjusted that on the cross slide. So the top slide is still set to 0. The cross slide now can be set to 0. I'm doing an 18 teeth per inch for this thread. I've got the top slide set to 0, the cross slide set to 0, and the tool is just and so scraping the inside edge. The tool is then moved clear of the workpiece. We can now readjust the cross slide to double the depth of cut, because this is a direct read and it takes it off the diameter, does this, which gives it 0.0712. So if I adjust this to 0.0712, trying to do this with one hand again, 0.03, 0.0712, is about there. We can then move this to 0 using the whole dial. Now that that's at 0, backlash is out, top slide is at 0 with backlash out. That should be your finished depth of cut. If I just move that in a little bit, should be able to see the finished depth of cut there. So now that you've got the finished depth of cut there, we can now wind the top slide in to clear the workpiece, and we know that when we wind this top slide back to 0, it should be the finished depth of cut. So let's give it a go. Difficult try to do it with one hand. Set on the slower speed, right-handed thread. 18 teeth per inch is C2SY. So that's C2SY. This machine can do metric threads and imperial threads. There's millimeters on that side, imperial on that side. 18 teeth per inch is C2SY. So let's see what 18 teeth per inch on the thread dial. It can be located in any of the positions on the thread dial. Let's adjust the thread dial in. Now we're going to increment it on the top slide, pulling it back towards us. So you're going to be taking it off the leading face and not on the trailing edge. Once you've cleared the tool within the bore, you'll be winding it in with your cross slide to clear it, so you can wind it back round and then increment it again on the top slide. Engaged. I've done the first pass, so now I'll just wind it, zoom out a little bit. So that's the first pass. This is still set at 0. This is at the moment set at 0.034, so it's just and so skimmed it. The top slide isn't direct reading, the cross slide is, so now we can wind it back from 0, wind it out of the to clear, back to 0 on the cross slide, and increment it again on the top slide. And in theory this should be pulling it back and just taking it off the leading face. And when this top slide gets to 0, it should be on full depth. Nice fit. Okay, I've just made a small recess on the outside edge of this, on the inside edge of this up to the threads. It's like a bit of a register so that it can slot over the top of this part of the thread there. Okay, what I need to find out is the distance of the step that I'm going to machine onto the nut. When the grinder goes into there like that, I need to work out measure the distance from the top edge of this to where the nut is going to touch onto the plastic register on the grinder. And I need to make sure that the nut tightens up onto this part rather than it touch the edge of the plastic part of the grinder. So I don't want the nut to go all the way home on the grinder, so that it pulls it tight around this tapered part here. So I'm going to push that grinder in as far as it will go using my knee, and measure this 5.68. So if that measures 5.68, if I make that step 5mm, it should leave the nut off this part here by 0.68 of a millimetre. So I should be able to tighten it up and it should pull the grinder into the holder reasonably tightly. And that's the orientation that the grinder is going to be, with the stop button up like that. So you've got access to the stop button, you've got access to the lock for the spindle. So the length of the step is going to be 5mm and the diameter of the step is going to be, that measures 23.83. 23.88 actually. 23.88 for the diameter. So it's going to be, if I said 23.8 for the diameter, give it 0.8 of a millimetre all the way around for a little bit of play. It should locate nicely around this part here, make it 5mm, which will make it tighten up nicely against that, and it should hold the grinder in position nice and tight. This step doesn't have to be 100% accurate, so what I'm going to do, I'm just going to scribe a line 5mm, which I'm going to work up to. So I'm going to use, this is what I normally do. I normally set this to, these are a very cheap set of vernier gauges. Set it to approximately 5mm, lock it in position. And now what I'm going to do, I'm going to set these verniers to 23.8. There's 23.8, near enough. Zero I'm out at 23.8, so I'm aiming for the zero mark now. So then I can measure the distance what it is now, and I know I need to take 4.75mm off that. 4.75. So what I'm going to do, I'm going to take a light skim cut. Need a bit more off than that. Okay, I set the scale to 0 when I did that skim cut. So now we can measure the distance, 4.51. That measures 4.51 on the digital scale. So I need to make that 4.51 off the diameter. This was set on 0 when I did that skim cut, so now I know I can wind that in to 4.51. This is a direct reading or diameter reading scale. So this should be going to double check it with the vernier now. That's on 3mm on the scale, and I needed to take 4.51 off. So it should on the scale be reading now 1.51. It's actually reading 1.54. So I need to take 1.54mm off. So now this scale should read 0. Reading 0.02, 0.01. That'll do. Okay, I've actually changed my mind about machining some flats on this. I don't really want to be putting a spanner on and tying it up with a spanner onto these plastic nuts, so I've decided to knurl this so that I can just do it by finger tight. So I'm going to skim this ever so slightly and then try knurling this. Frightening working right up to the jaws, especially with power feed. Should be enough on there to be able to knurl it and then part it off, I would think. I'm going to try and knurl it using the tool that I'm actually trying to repair. It's extremely close to the jaws, probably about 2mm from this part of the jaw here, so I'm going to have to be very careful at doing it. bastard. But it's moved out of the jaws. Not enough hole on the jaws. I'm going to set that at 45 degrees so I can skim the edge of it off, put a bit of a taper on the edge of it. That's knackered that tip up, and I've just realised what I've been doing wrong. Mistakes that you make when you're rushing. That's what's happened to the tip. Let's get it to focus. And that happened because I was going in reverse to do that, and I forgot to stop it and put it forwards to work on the front of the cutter. This is the finished grinding attachment that I've made. I originally machined this part out here, out of an old piece of metal that I found in a skip. My brother actually welded this piece on because I'd actually run out of gas for my welder, and he took it to work to weld it up. And to be honest with you, he's done a very good job at welding the part together. He's basically welded this flat piece onto this. This flat piece then can be mounted into a quick change tool holder, like so. I'll just nip them up. And then the grinder, you can take this part off here. The grinder then slots in to that part there, like so, giving you access to the lock button. I've then made this, I've knurled the outside edge of this so that you can do it finger tight. And then that screws over the top of that.